Okay, so let's see if we can position this a bit better. I want you guys to see this a bit better. Oops, let's go a bit further up. A bit less. Actually, let's go a bit less. Okay, hello everybody. Um, if you're tuning in just now, I have in front of me a control board um, from a Carrier or Carrier. I don't even know how to pronounce it, but yeah, I think it's a Carrier furnace, or at least a whole system furnace. And I have a little test jig, as you can see, set up. I have a light over here, and I have a bunch of wires going to a bunch of places. But basically, what's happening is here I have this control board from this furnace. Uh, this was given to me by a customer. Actually, he came back now a couple of times, or at least he came back twice now. Actually, first time when I had it, and the second time not too long ago with the board. What happened was his furnace didn't or stopped working one day, and he didn't have heat anymore. So he was like, "What's going on?" So, anyways, he had somebody go over to his house, a HVAC guy that knew and understood furnaces well. Uh, Went through a bunch of stuff, diagnosed, and said, "No, it has to be the board. The board is the one that's defective, whatever." Right. So I was a bit suspicious because at least the way that was described to me, how he did his testing, I thought it might have been a bit too fast or a bit too hastily. So, but he turns out he was correct. So kudos to him. So he takes the board. This is my customer. He takes the board. Now he knows that apparently or now he knew from the HVAC technician that this board was suspected to be defective. Takes the board. He brings it to somebody he knows, uh, and that person changed a couple of parts, and I ended up actually having to fix it. Changes two transistors here. We have two BJTs. Actually, no, this is a BJT. The other one's a MOSFET, if I'm not mistaken. So he changed these two, and then he changed one of the relays because he noticed that the relay was weak or didn't work properly or whatever. So he did all that. Still didn't work. All right. Then my customer, he brings it to me, and I'm looking at it, and I'm like, you know what? You can't see it now because now it's flipped down like this. But I was telling my customer even before doing any work, I said, listen, this guy that you brought it to, um, didn't do a good job. Unfortunately, he changed the relay, yeah, and he changed his two transistors, but he didn't even have to. Uh, and the fact of the matter is, he did a poor job, in my opinion, actually. Um, the transistors, he damaged the traces where these transistors connect on the board over here under the board, and he did do the relay somewhat properly, but still the solder wasn't so great. um what else did he do? Yeah, and anyways, it didn't work. So I went back and forth with it. I checked everything out and I was testing it, and I thought also there was nothing wrong actually. So I simulated a call for heat. So I used my jumper wire here that you can probably see off to the side. So I took this jumper wire and I connected it to the right terminals, whatever. So I simulated a call for heat to the board, and it seemed like it was working fine, the board at least. So I was like, okay. I mean, I told my customers, I don't think there's anything wrong with this board. It might be something else on your furnace. So he goes to the furnace. He troubleshoots the furnace. He tests all the other stuff that's on the furnace, the limit switches, pressure switches, and all that stuff, whatever. And he was saying, yeah, everything's fine. He cleaned everything. He was like, there's no problem with it. And then we start. I'm on the phone with him, and we're troubleshooting from a distance. From remote, or at least I'm troubleshooting remotely because I'm not at his house. So he has a meter, a multimeter, whatever, like my not like my Fluke here, but something similar to the Fluke. So he had his own meter, whatever. So I'm like, okay, measure a couple of points, and see whether or not you're getting the right readings. And then we tested the igniter, which is over here. So this is where I actually have this lamp connected to. So this is like my igniter. I'm using a lamp to simulate the load of the igniter on the furnace, albeit the igniter actually pulls much more power. This is a 100-watt bulb, so this is pulling maybe not even more than 1.5 amps there, so 1 amp or whatever. because this is running on 120 actually. So there's two voltages that really control it or make this board work. There's this green wire here that you see off to the side. This is the 24 volt control side, the 24 volt AC actually. And then there's the 120, which is on this black wire over here. So this is the 120 that powers this board permanently. And then you have this 24 volt AC that controls like the control side of things, more or less. So everything was correct. We checked all those voltages, neutrals and connections and everything. That was all good. But then, like I said, when we went to the igniter, we were looking at the igniter, and turns out it wasn't working properly. So we simulated the call for heat and everything. We were testing that too, because there's a way to take this board, and I'll show you in a second. There's a way to put this into test mode, this board, so that you can test these components like the igniter, the fan, and all these other pieces and whatnot on the furnace. So when it came to the igniter, he was measuring on the connector here, where this goes to the igniter and the fan inducer motor. So when we were checking the voltages for the igniter, we weren't getting our 120, because what it is basically, we have two relays here. One relay is for the igniter, the other one is for the inducer, if I remember correctly, the fan inducer motor. And the way this works is this relay controls the inducer motor. Sorry, this relay here, the black one, controls the igniter, and this blue one controls the inducer motor. And I think actually these two work in conjunction somehow. So these two right here. So this is for the inducer motor. This is for the igniter itself. So the igniter, I think it draws 800 watts, maybe something like that. I don't remember. And this switches it. So when this clicks, it turns on and off the igniter or whatever on the furnace. So we weren't getting our 120 AC on this pin. So we were like, okay, there's something maybe wrong still with the furnace. We were checking other pieces and whatnot, and I was guessing, and I was saying, I was like, look, listen, there's a chance that there's maybe a connection broken, even though we changed, or the guy that worked on this board before me changed this relay. I'm like, listen, there might be still things that are wrong under, like in terms of connections and traces. So I had checked this already before, and I was like, there's nothing wrong there. So I was doubting myself. All this to say, long story short, I get the board back. I tell him, okay, listen, he had bought a new board. Because what happened was he had bought actually a new board, or a used board, from apparently a reputable place. He put it in the furnace. It worked for, I think he was saying, 20 minutes, and then it stopped working. It died also. So my customer has not been lucky with control boards recently. So that was his situation. So I told him, I said, listen, send back the one that you bought. Bring me back this one, because I was a bit busy, I will say, at the time, actually. So I not that I looked at it too quickly, but I looked at it, whatever. But then I didn't have more time to look at it because I was busy with school. So now that my school is over, at least my semester is over, I have more free time. I told him, bring me the board back. I'm going to have a look at it, and I'm going to test, whatever more stuff, and I'll see what's wrong. So we found out, or at least in my testing, what I found out, basically, the way this board works, more or less, we have the main microcontroller, which is here. This is it's a microchip microcontroller, but I don't know if this is a PIC16 or if this is an Atmega. I think this is an Atmega 328P. And the reason why I'm uncertain is because the number that's on this is not a standard number. It's a custom, whatever, unique number for carry in this case. But if you do punch this number in Google, it actually shows up as Atmega 328P, whatever. So that's what this chip is basically here. It's just an 8-bit microcontroller. And then around here, we have some 7400 ICs and a lot of passive components, K resistors and capacitors and whatnot. This is the block, the terminal block that connects to the thermostat on the wall in the house. And then we have a 3-amp fuse on the control side. So in case this blows, and I actually did blow it by accident, this is the original one that was in here. I shorted 2 of these pins by accident, and I blew the 3-amp fuse. So that was a good catch. But I'm also on a limited supply here also, so I can't really blow anything up that easily. But yeah, basically, again, we fixed that, or at least, sorry, not fixed it. I'm saying, yeah, that's what that was. We have the neutral connections over here. We have a couple more relays here, and then the 120 in the furnace connects here. And then there's the secondary side over here. These two pins over here. That's the 24-volt AC that comes in and powers the control side on the circuit board. But then basically, what I did was I troubleshooted the control side of this relay, because this relay had been changed by someone else yet again, because when I give this board back to my customer, he had brought it to somewhere else again, and the guy changed the relays again, and I told him I'm not sure why he did that. There was no need, because these relays that were here before were actually fine. So again, the guy, someone else, that didn't know exactly what was going on and was just throwing guesses and the parts cannon and whatever, and was saying, yeah, it has to be this, but of course it wasn't. So I started troubleshooting the control side of this relay, and I figured, I'm like, let me trace the connection that, controls the coil side, right? So I traced it all the way back to this chip right here. Actually, this is a Darlington NPN whatever, or at least a Darlington power, not power transistor, but a Darlington array chip here. So basically, we have all the signals that are fed from the microcontroller on the 5-volt side, because this is 5-volt logic that comes and it feeds these pins. And on the other side, we have the signals that go to this relay, this relay, this relay, and a couple other components. And that's what actually actuates this. So it's a power transistor array, a Darlington power transistor array, according to the datasheet. This is a ULN 2023. No, it's a ULN 203A IC. So I got a replacement. This is the old one that I had pulled out. It's in the bag, and then this is just a spare fuse. Oops, yeah, that's just a spare fuse. This is the IC that I pulled from the board. So I was able to get this IC, thankfully, from my local parts supplier. But yeah, so now what I'm going to do is I'm going to test this. So that's the long-winded story of what the hell happened with this board. So I think I might be omitting a couple of details, but that's pretty much the gist of it. That's what happened. Yeah, I'm getting tired of even my own stories I'm talking about. No, but now what we're gonna do is I'm gonna show you this board in action, and I'm gonna show you, if ever you have one of these boards, how you can test them actually. So basically, what you want to do is you want to disconnect the thermostat. So again, this is the terminal block for your thermostat over here. Disconnect the thermostat, and then locate the 24-volt pin, 24-volt COM, and this is, yeah, in my case, it's called COM 24. So locate that pin and get a wire like this, so like a jumper wire like this, out of alligator clips or whatever. So you clip one end on here, on the pin here where it says COM 24 on this block over here, and then you take your alligator lead. You're going to short it for 2 seconds with a pin here called test twin. It's a pin that's on the board over here. You can't see it, but it looks like a spade here on the board. It sticks out, and it's labeled test twin. So you take your alligator leaded wire, whatever, you take it and you short it with this pin for 2 seconds. Now, I'm just going to clear some stuff out of the way before I do that, because I want you guys to see something when it's doing the testing. So I'm going to put this here. Actually, I'm going to put this here. I'm going to put my multimeter down on the table. I want to see if you can see my multimeter here. Okay, let me see if I can get this in the camera. Oops. Let me see if I can get this in the camera angle. This is not great. Okay, let me see. Can I? Well, I can't put it there. Let me see if I can put it there. Yeah. Okay, you know what? That might just work. Let me see here. Oops. Yeah, alrighty. So, all right. So just actually to show you a couple of things that I can do right now. Let me just get this out of the way. Let me put this to AC just to show you that we have our 120 coming in. So if I measure here, and I measure between the neutral, yeah, we have our 120 AC. There you go. That's our 120 AC that's coming in the board. That's good. Now, to show you that we have our 24-volt AC on this board present right now, we put my pin there, put my pin there. There you go. So 23.9, call it 24. So that's our 24-volt control. So those are the two voltages that I confirmed with my customer, and he said that it's there and everything, it's working. Now, if you look, for example, here, so if I do this like this now, if I put one pin on the neutral, I'm gonna put this to AC. Yeah, we're on AC. That's good. So I put it here. Now, if I check this pin here, we should be reading 0. Yeah, there you go. So we're pretty much at 0. So the relay is not engaged. But now what we're going to do is I'm going to put this on DC volts. And I'm going to put one probe here. And you're going to see, so on this pin here, on this chip that I replaced, when the inducer, basically this lamp here, I'm using not the inducer, sorry, the igniter. I'm using the lamp as my illustration. This is my igniter, not my inducer load, because I don't actually have the inducer the igniter with me here. So I'm using this lamp, a 100-watt bulb, as a load. So if you put your pin here, your probe here on this pin, number 2 on this IC that I changed, when the microcontroller tells the relay to click on, you should be reading 5 volts on this screen. So we're going to do this in real time. I'm going to initiate the test sequence by shorting the COM24 pin on the thermostat whatever block here, and I'm going to short it with the test twin connector for 2 seconds. 1, 2. So now we initiated the test sequence. The LED here is going to start blinking. This is the last error code that was stored in memory. It'll reiterate it. I think it's going to reiterate like 2-3 times, and then it starts the test sequence. You might hear the relay click here in a second. So I'm going to put this here. So you'll see now in a second when the igniter gets power, you'll see it on my meter, and you'll see the light light up actually. There you go. And we have 5 volts. So that's the 5 volts coming from the microcontroller. And as you can see, the lamp is on. It only stays on for, let's say, I think about 10 seconds, and then it turns off because this is just a test. It doesn't actually keep it on. And now it goes to the next component and it tests the next component. And you'll hear the relays click on and off here in a second, because that's what this is doing now. It's just a component test. So if you want to check if any components are defective, this is how you do it. You initiate, sorry, the test sequence, and for about 2-3 minutes, it goes through all the components, and if you see one of them is not working, then you know, okay, there's a problem with, let's say, that component, or at least somewhere on the board that controls that component. And someone's calling my phone. Let me see if I can get to it. Son of a gun. Oops, hang on a second. Hello.
Oh,
Yeah. Sorry, that was a buddy of mine. He called me, and I just had to check about what was going on. Okay, so good. All right, now, so as you saw, the test succeeded. The board is fixed. I think I'm gonna leave it at that because there's not much else to tell you guys. Just figured maybe this might help someone that has a board like this and needs it to be fixed or whatever, because I think these boards, you find them a lot in the, well, it's a furnace control board, but uh, I'm not sure if they're used in other products that Carrier has for any by any chance. Um, so yeah, hopefully this helped you guys, and I think I'm gonna leave it at that because that's pretty much just what I wanted to show you. I didn't want to make this too long. Um, so yeah, that's how you for a long time you check a board and you see what's going on with it. But anyways, hopefully that was maybe a little bit and entertaining for you guys. If you like this, please just consider subscribing to the channel. Drop a comment down below, and if you have any questions, I'll try to answer them. I know I've been getting a lot of questions on some videos, but there's so many that I'm losing a bit of track on answering them all. Uh, but I'll try my best to answer them. Now that I have a bit more free time, I might go through all of them and answer them quickly. So yeah, like, subscribe, and stay tuned for the next one. I'm gonna end it here for now, and that's it. That's all. All right, guys, take care. Bye bye.